Case in point, you're supporting a mid-sized logistics company that's based in Saudi Arabia, and they're evaluating an HRMS payroll solution. An AI tool generated a vendor shortlist for you. It gave you recognizable names with a list of features and the platforms that it offers. It gave you competitive pricing, and you use that list and you send across for review to your team or to the client. And you find out some of those names in that list did not comply with GOSI or Mudat, and one lacked localization for Saudi labor laws, and other didn't even have the regulatory clearance to sell in KSA. On paper, the list looked solid. In reality, it wasn't deployable. So this is where RAG, or the Retrieval Augmented Generation system, matters. It's not just to surface information, but it's also to contextualize it with compliance, region-specific filters, and procurement logic for that particular query that you asked it. So here's the thing. Large language models like GPT-4 and Claude Llama, they're trained on a fixed data set. Basically, it's a snapshot of the internet at a point in time, which means three big problems. They go out of date. They don't know your internal data. They make stuff up when they're unsure. So if you're building anything serious, say a support bot or internal knowledge assistant or a medical tool, you just can't rely on the model's memory. What you need is a way to inject accurate, real-time knowledge into the model without retraining it from scratch. That's what RAG does. It was first introduced in 2020 by Facebook's AI research team. And back then, it was a cool academic concept that combined research or search with the ability to generate text and make AI more accurate. But honestly, most people weren't ready. LLMs weren't widely used. The tools were hard to set up, and the use case felt kind of niche. Now, fast forward to 2023 or 24, suddenly everyone's using ChatGPT, and we're all starting to see the same thing. The answers sound smart, but sometimes they just got it wrong. And that's when RAG started to make sense. And it was like, wait, what if we could ask the model to check the facts first from a set of documents before it answered? So at the same time, the tooling also got better with solutions like LangChain, the Llama Index, or vector databases like Pinecone. And cloud platforms as well started offering RAG-ready services. So in a way, we started to catch up, and the technology was ready to service the requirement. So what is retrieval augmented generation? It's basically, instead of asking the model to answer from memory, you make it do an internet search or a Google search to answer the question. And then it responds back with what it finds. It's not literally doing a Google search, but it might be looking at your own knowledge bases or your documents or PDFs that you give it access to. The process is you ask a question, the system searches your data to find the most relevant document. It combines those documents with your question, and then the LLM generates an answer using both the documents and its own knowledge. So now the model isn't guessing, it's actually reading through context and actual information you've given it. And this makes the AI more trustworthy, more up-to-date, and it's more aligned to the actual knowledge that you wanted to know. Now, there are a few real-world examples coming up. So let's say you're working at a bank. You have internal policies that are scattered across multiple PDFs, say 1,000 PDFs. You build a chatbot using the RAG methodology, and when someone types in, can I approve a specific type of wire transfer without any compliance reviews, the system retrieves the exact policy document where this rule is mentioned and includes it in the prompt. And then the LLM could reply to you about specific answers. For example, no, the transfer is not required and doesn't meet the compliance policies, and this is as per this particular document, this so-and-so section. It's clear, it's articulated, and it's cited. That's a use of RAG. The example that I showed you is something that Morgan Stanley built as an RAG assistant for financial advisors to help them answer these specific policy-based questions. So how does it actually work? So let's try to get into a little bit of technicalities around it and what happens behind the scenes. So there are 4 moving parts. First one is something called as an encoder. This turns your question or a part of the text into something called a vector. Think of it like a smart number that captures the meaning of what you're trying to ask or that meaning of that particular text. Second is a vector database. It holds all the documents as vectors and it stores it somewhere. and it acts like a database of sort. Next is a retriever, which is, think of it as the ability to search this database, and it finds the closest matching vector within the documents that you're trying to query, and it retrieves it back. And then there is the LLM. It takes the question and the documents with the added context that it's got from the documents, and then it writes the answers. You can build this using tools like LangChain, Haystack, or Llama Index if you're into open source. And you can go with managed platforms if you want, like Azure, Google Vertex AI, or AWS Bedrock to implement a RAG system. Now, fine tuning versus RAG. Now, you might be wondering why not just fine tune the model with additional data. Fine tuning means you're baking your data into the model itself, and that's great for static knowledge. But if your data keeps changing, you need to retrain, and that's pretty expensive. With RAG, your model stays general purpose. You just update the database. For example, you need to add 10 new policy documents. You just re-embed and upload them. So there is no retraining required. And as a result, there is no downtime in some sort. Now, of course, RAG isn't perfect. There are a lot of limitations. It adds some level of latency, right? So retrieval takes some time, not much, maybe a second or two, but it's still there. It adds a bit of complexity because now you're maintaining a database. Now you have a retriever and then there's a model. And if the retriever picks up the wrong documents, the model might still hallucinate. So you're still trapped in that problem of incorrect information. So this isn't a silver bullet, but you still need good infrastructure. You need clean documents and you need a method to evaluate it in a smart way. So in most cases, the gains in accuracy are truly worth it. So it's still worth the effort. Now, here are a few tips if you're thinking about building an RAG system. You need clean and chunked documents. What it means is you need to break the files into small, meaningful sections that is easier for retrieval. Embedded with good models, OpenAI and Cohere and Hugging Face all offer solid models for you to use. And you should embed it with reliable good models if you want better outputs. You need to limit the retrieval to the top 3 to 5 chunks because too much context kind of confuses the model. So you need to figure out ways that you're picking up the right chunks for that specific query. And that's where, to a certain extent, the capability of setting up the right RAG system comes into play. The prompts also need to be really clear. If you're creating an application, even if you're using RAG to retrieve information, the prompt that goes into the model has to be compatible or modified in a way that you're using the retrieval docs and to cite them if possible. And you need to evaluate constantly. So you use tools like Langsmith or PromptClair to track accuracy over time. The space is moving fast, and we are seeing early signs of the application of RAG in the form of multi-model RAG or real-time RAG systems. So these are where the retrieval is not just text, but it's also images, charts, and videos. And you might be combining the live web search and API data with the LLMs. And these are some advancements that are happening, and you might be already using some tools that have these capabilities. So if you're building tools or businesses around AI, it's very important that you understand this because LLMs aren't enough anymore and everyone's got access to GPT-4. What really matters is how you ground it with real life knowledge. So that's RAG, Retrieval Augmented Generation. It's the system behind smarter AI tools. So if you want to make your LLMs to stop guessing and get more accurate information about things that it might not have access to, then you need to use RAG. So if you're building AI products, RAG should be part of your toolkit. So I'm hoping this was helpful. If you did like it, hit the like button. And if you build something with RAG or want help, drop a comment. I'd love to hear what you're working on. And thanks for watching, and I'll see you in the next one.